SpaceX is currently leading the public and private sector, dominating the commercial rocket market. So in today's episode, let's take a little bit of an introductory dive into how Elon Musk plans to colonize Mars using SpaceX's reusable rocket technology and their upcoming next-generation interplanetary transport system. This is your host Praveen, and you're listening to Musk Unloaded, Space Podcast. Musk Unloaded Space Podcast is brought to you by Newslanded LLC and Appleosophy Media. Newslanded LLC is a media company that aims to bring news from all corners of the world in one place. Appleosophy Media is the home to all Appleosophy brands, and Appleosophy reports on the latest Apple news and rumors. Visit www.appleosophy.com for more details. So let's say the year is 2040 and you live in California. You need to attend a business meeting in Tokyo, which is around 15 hours by flight. Okay, that's great. But what if I say that in 2040, you could reach your destination in around 30 minutes? That's right. This could be only possible if you used space rather than air as your transportation medium. Space travel is becoming increasingly popular, especially with the onset of private companies like Blue Origin and SpaceX. They've been developing rocket technology that hasn't been even thought of in the past 10, maybe even 20 years. But the type of technology that's being incorporated right now in rockets is so advanced and so complex, it takes a lot of time and only experts could really understand the importance and the significance of such technology. Now, before the Wright brothers invented the first airplane, people thought of air travel as an extremely crazy thought. Like, we could not even believe that one could fly, that too for sustained times such as 10, 15, even days, weeks, months at a time. But right now, we have aircraft, autonomous drones that could fly for months at a time. We have large passenger aircraft that can fly up to 14 hours at a single flight. Now, with such aircraft technology available to us, why does it seem impossible that we could, travel through space from one point on Earth to another, or that we could set up colonies on Mars, that we could start a huge base station on the moon? Well, all of this is entirely possible, and this is not just speculation. Technology is being built right now. We are actually actively testing technology which could be used in aircraft or spacecraft that could potentially take us to Mars or even beyond that. So let me just give you an example scenario which SpaceX showed off. Let's say you want to get to Tokyo, as I said. If you lived in California, you'd probably go to your nearest spaceport, which I would expect would be in San Francisco. From there, you would suit up along with 100 other people and climb on board a ferry which would take you to an artificial floating platform where you would see a large towering rocket made completely out of stainless steel. You and those 100 other people would board the spacecraft using a large elevator, from there a bridge which leads onto the spacecraft. So this is what SpaceX is developing, and this rocket system, this interplanetary transport system, is called the Starship Super Heavy. So Starship is the upper half of the rocket where people will actually be boarding, and the Super Heavy is the bottom booster of the rocket. So what SpaceX aims to build is a rocket system that is completely reusable, that could be used to take people on one point on Earth to another in around 30 minutes. Now this seems crazy, seeing how almost everyone has faced traffic situations where it would take more than an hour just to go a few kilometers. But going from one point on Earth, like from one country to another country in just 30 minutes is completely insane. Now, SpaceX is making this possible, and they've made a lot of breakthroughs in rocket technology and rocket science technology, which is leading them to develop this rocket system right now as we speak. Now, obviously, one will think, it costs billions and billions of dollars to develop and build one rocket. How on earth will it be possible for a person to afford a ticket to board a spaceship? Now, this is where the concept of reusability comes into play. Until the past few years, most rockets, or basically almost all rockets, have been expendable, meaning that once the rocket is used, it is completely useless after that point. Almost 90% of a rocket is completely burned out and useless and just thrown away in the upper atmosphere, where it would just burn up as it descended. Now, how does SpaceX solve the equation of making a rocket completely reusable? So there are certain technological factors that come into play which allows SpaceX to make completely reusable rockets such as the Falcon 9, the Falcon Heavy, and the Spaceship Star Super Heavy, which they're developing right now. So what I'm going to do is I'm just going to go through some of the most important technological factors and what SpaceX has done in order to solve these problems. So we won't be talking too much in depth, we'll be saving that for other episodes, but we're just gonna go over a little bit of an outline. So first, we need to understand the concept of a rocket. A rocket isn't defined by something which is tall and long and goes into space. No, that is not a rocket. A rocket is defined by a vehicle which uses the concept of a rocket engine. So you would ask, what is the difference between a rocket engine and a normal passenger aircraft that everyone travels in? So we need to talk slightly about the concept of thrust. Normal aircraft engines, which are called turbofan engines, use these large spinning blades in order to suck in large volumes of air, which is then injected with jet fuel, combusted, and pushed out through the exhaust. Now, a rocket engine cannot use these same principles, as in space there is vacuum, meaning there is no air for one to inject fuel into, or compress, or basically create any type of explosion. Because in order to burn something, you need oxygen. And with the absence of air, there's nothing to burn, so the concept of an engine won't work in space. So a rocket engine basically is a type of jet engine which carries its own set of oxygen fuel. So a rocket engine has two sets of fuel. It has its normal combusting fuel, which most engines use hydrogen, and we have liquid oxygen, which is what we use in order to burn and combust our fuel. So rocket engines basically do not use external air, as there is no external air once we reach higher altitudes, and uses its own set of air, or basically it carries oxygen. So now that we know how a rocket engine works and how a rocket is defined by, we can kind of understand that a rocket engine is basically a controlled explosion. It's a large explosion, a very powerful explosion that we control, contain, and push in one direction. So with the early stages of the rocket engine, once you started the rocket engine, you could not stop it. Because once you start an explosion, you cannot stop it as well. You could also not control the throttle, or basically you could not control the amount of thrust that a rocket engine provides. So with recent rocket technology and with the dawn of SpaceX, we have such advanced rocket engines which could be controlled in every single way. So basically, one of the main requirements for a reusable rocket is the ability to restart a rocket engine multiple times without it failing. So this is where SpaceX developed a restartable ignition system for the first booster. So restarts are required in multiple places. Once when in the upper atmosphere, when the rocket is traveling at supersonic speeds. So this is to reverse the rocket's direction away from its trajectory and put it back on a path towards the launch pad. So this is not viable when the rocket is traveling at much higher speeds when it's going further away. So in those times, again, the restart is required to put the rocket on a path towards a platform where it could go and land. So once the rocket booster is traveling at supersonic speeds entering the Earth's atmosphere, we see the heat begins to develop around the booster and it starts to hit a transonic speed. So once it does that, we need another restart in order to slow down the rocket again. So basically what we're doing is we are using the same rocket engines that we use to take off. We're using them to fire in the opposite direction in order to slow down the booster, which is now traveling in a vertical direction towards Earth. So once it gets slower and reaches a subsonic speed, we need another controlled burn in order to slowly reduce the rocket's velocity to zero, bringing it to land on the Earth's surface. Now this is only half of the story, as there's a lot more complexity on the landing situation. When a rocket is coming into land, we need to be able to sufficiently control the engine so that we can slowly throttle it down to zero. We can take the example of the Falcon 9. So a lot of you would have seen videos of the Falcon 9's landing slowly coming down vertically and hitting the launch pad. What a lot of people don't know is that the Merlin 1D engine that the Falcon 9 uses, there's only one single Merlin 1D which is firing and which is used in this landing procedure. Also, this landing procedure is called retropulsive landing, the form of using the rocket engine again in the opposite direction in order to land the vehicle, in this case, the rocket booster. So when the Falcon 9 is coming down to land with its single Merlin 1D engine, we need to understand that the minimum thrust that you could provide, even with the most advanced Merlin 1D, with like the most minimum thrust that the rocket engine produces when it's turned on, is still exceeding the weight of the Falcon 9 booster. So there's no way that you could basically have such a minimum amount of thrust such that the rocket booster hits the Earth's surface in a most controlled way. So what SpaceX does is they start to throttle down the rocket engine once it nears the surface, such that by the time the booster hits the surface, the rocket engine would have throttled down to zero. So again, this is because we could not effectively control precise amounts of thrust, seeing how a rocket's engine's minimum thrust is much more compared to magnitude of like the entire weight of the booster. So in order to achieve such precise amounts of thrust and such precise calculations of when and where these restarts of the engine should happen, it requires a large amount of software and machine learning. SpaceX uses extremely calculated maneuvers such that the rocket engine itself can calculate its re-entry points, such that the booster can accurately calculate and burn the rocket engines in the required quantity in the required direction in order to follow the correct path. This is just one of the advancements that SpaceX has made in regards to developing this reusable rocket technology. There are so many other forms of technology that they've developed, like a new altitude control system and how they control the rocket booster's direction when it's traveling through hypersonic, supersonic speeds, and also a lot of other things such as landing capability, landing accuracy, a navigation system, a thermal protection system where it could protect the rocket booster from the high temperatures when re-entering the atmosphere. And that's just some of the developments that SpaceX has made in order to build and develop and test this type of reusable rocket technology. Now, what does all this have to do with getting to the moon or getting to Mars or going from one point on Earth to another in just 30 minutes? Well, it has everything to do with this because the type of technology that SpaceX is testing right now is going to be the same types of technology incorporated into these type of reusable spacecraft. Now again, I told you that it takes billions of dollars in order to develop a rocket system like this. So in order for this to be cost effective, especially for a private company like SpaceX, the order of magnitude of the cost of launching a rocket and retrieving it again must come down by multiple degrees. So there are multiple ways that SpaceX aims to reduce the cost of space travel. So one is their vertical integration when they're building their rockets. A lot of the hardware and all of the software that SpaceX uses in order to build their rockets is completely done by SpaceX. So this drastically reduces the cost of building a rocket. If you look at other companies such as Boeing or Lockheed Martin, they source a lot of factory plants and a lot of the manufacturing of the rocket actually takes place in multiple countries. And then they come together to build the rocket, which is again extremely cost inefficient. Number two is SpaceX aims to use the rocket multiple times. SpaceX says that every single part of the Starship Super Heavy system can be used more than 100 times, with the heat shield up to 10 times. Now, this again brings down the cost of the rocket by 2 degrees if you're using the rocket 100 times. And also, another thing, SpaceX plans on fitting more than 100 people in every single Starship, which again brings down the cost by another 2 degrees. Now you might be thinking, how will one possibly fit 100 people onto one rocket? SpaceX says this would be possible because of the new rocket technology that they're building, the Raptor engine. So the Raptor engine is tested to have one of the highest thrust to weight ratios of any rocket engine and will also incorporate all the advancements of technologies which was built into the Merlin 1D engine. The Starship Super Heavy will have multiple engines, more than 20 plus Raptor engines, which enables a high amount of thrust, which will eventually be able to take this rocket from the Earth's surface to other celestial bodies. So let's try and compare the upcoming Starship Super Heavy system with the world's most powerful, most largest rocket built up to date, the Saturn V. So a lot of you might not know, the Saturn V was built by NASA and it was used to carry the Apollo astronauts to the moon and back. Now obviously, due to the distance that this rocket is traversing, you can expect it to be extremely large, which is why some might call it the most greatest engineering feat of mankind ever until date. So if we compare SpaceX's upcoming Starship Super Heavy rocket to the Saturn V, you would see that they both have an ultimate goal, reaching the moon or reaching Mars or beyond. So the Saturn V's capacity was to carry 3 people to the moon. The Starship Super Heavy system is aimed to carry about 100 people to Mars and maybe even beyond. So you might be thinking, how, when we were able to only take 3 people to the moon, is SpaceX able to carry 100 people to Mars and beyond? Well, this mainly lies in the type of technology and the type of concept that each rocket uses. The Saturn V was an expendable rocket built out of 3 to 4 stages, and each stage is expended with a different rocket engine optimized for each altitude of its travel. Also, the Saturn V was using rocket technology which was very old and again unoptimized, unlike SpaceX's Raptor engines. The Raptor engines have such a high thrust to weight ratio that it does not require the amount of space and the amount of stages that the Saturn V uses. It is also highly possible that SpaceX may be able to carry many more people, more than just the 100, when using the Starship Super Heavy for Earth-to-Earth transportation. Now this will be possible because SpaceX won't be actually aiming to put the spacecraft in orbit or to exit Earth's gravitational influence. SpaceX just wants to use the rocket system in order to go high enough so that the rocket could go fast enough in order to reach another point on Earth, without the influence of air resistance or any other resistance that an aircraft would normally encounter. There's a common misconception of how space is defined, and also the amount of energy or the speed that a rocket has to travel in order to escape Earth's gravitational pull. So first, let's see how space is defined. Usually, a lot of people define space as 100 kilometers starting from the Earth's surface going up. So if we take a look at the first rocket ever built, which was built by Nazi Germany, the V2, that rocket, or basically it was a ballistic missile at the time, it was able to achieve the approximate height or altitude of 100 kilometers. So basically, that ballistic missile technically reached space. So taking that into consideration, that ballistic missile only traveled at about 14% of Earth's escape velocity, which is like 11.2 kilometers per second, as some of you might know. Now this 11.2 kilometers per second is just Earth's escape velocity at its surface. Escape velocity is not like a generic term, which like when a rocket has to achieve this speed in order to escape Earth's gravitational pull. Well, yes, a rocket does need to achieve that speed in order to escape Earth's gravitational pull, but a lot of people do not know that the escape velocity is actually different at different altitudes. As you go higher and higher, the escape velocity drops, eventually becoming 0 when you are right outside Earth's gravitational pull. If we take a look at the Saturn V, which was the rocket that was used, again, to take people from Earth to the moon, basically the Apollo missions, the Saturn V's top speed was approximately 2.76 kilometers per second. So that is about 25% of Earth's escape velocity. Now you might be wondering, how on earth did that large rocket escape Earth's gravitational pull if it did not even hit 25% of Earth's, escape velocity? Now again, we are talking about the Earth's surface escape velocity, which is 11.2 kilometers per second. As the rocket goes higher and higher, like I said, the escape velocity drops. Technically, if I had a rocket that traveled at 1 kilometer per second, I could keep going slow enough such that eventually, at one point, the escape velocity would become 1 kilometer per second, which is where I would be able to escape Earth's gravitational pull entirely. You can even travel at 1 kilometer per hour. You could go really slow, but again, why rockets tend to achieve the escape velocity faster is because you could not sustain high speeds with a rocket engine if you want to try to reach Earth's, escape velocity and eventually escape Earth's gravitational pull. Now, the aim of the SpaceX's Starship Super Heavy system is not to reach escape velocity or even orbital velocity, which is the speed required in order to put a satellite or a spacecraft in orbit. The goal of this SpaceX's Starship system is to basically put this aircraft at an altitude high enough where there's minimum gravitational influence so that the spacecraft can travel at a high speed, which it could reach its destination much faster compared to traveling by air. So I've been talking again about the SpaceX's Starship Super Heavy, but the Starship Super Heavy is actually two parts. The Starship being the actual spaceship and the Super Heavy being the actual rocket booster which carries the spaceship into Earth's upper atmosphere. Again, the goal of the Earth-to-Earth system is not to escape or even go into orbit, it's just to achieve a high speed at a high altitude. So let's break down what makes the difference between the Super Heavy and the Starship. So let's just take this with an example scenario. Let's say you are boarded on top of a Starship spacecraft, on top of the Super Heavy booster, and you're leaving to, let's say, some other country. And when this rocket booster is taking off, it uses the combined power of multiple Raptor engines in order to push the rocket booster Super Heavy along with the Starship, which is attached to the top of the rocket booster, into Earth's upper atmosphere. Now again, when the Starship Super Heavy reaches the upper atmosphere, the first stage, the Super Heavy, will detach from the second stage, Starship. Once this maneuver is completed, the Super Heavy will return and refire its boosters and put it back on a path towards the launch pad. Once it reaches the launch pad, the Super Heavy will use the same retropulsive landing techniques used by the Falcon 9 booster in order to precisely land with extreme precision within just a few centimeters accuracy. Now, once the Super Heavy lands back on the launch pad, another Starship is placed on top of the Super Heavy while the Super Heavy simultaneously refueled. The Super Heavy can then again take off with the new Starship towards another destination. Meanwhile, while all this is happening, our original Starship is traveling towards its destination, let's say some other country. Once that Starship reaches the destination, it uses the same retropulsive landing techniques that the Super Heavy uses and that the Falcon 9 uses in order to land on its landing destination. Once people have disembarked from these two Starship, that Starship is then placed again on top of another Super Heavy in that location, where it's then simultaneously refueled and it takes off again. You can basically think of this Starship Super Heavy system as a two-part aircraft. Instead of a single piece which lands and takes off again and again, we have a two-part system in which the top part is used to carry the passengers and the bottom part is used to put the top part into the upper atmosphere. The goal is to make this rocket reusable multiple times, more than 100 times, by the various improvements in rocket technology and materials technology that SpaceX is currently developing or even completed developing. The Starship Super Heavy system aims to replace SpaceX's existing Falcon 9 and Falcon Heavy rockets, making an extremely large and expensive rocket system that can be used multiple number of times in order to carry large amounts of cargo. The important thing is that SpaceX manufactures this rocket system in a large quantity, basically mass production, because only mass production can bring down the cost of the rocket significantly enough such that it is useful for the private sector in terms of commercial travel and, to replace the aviation industry. Now again, we are talking about this rocket in only one perspective, using it to travel on one point of Earth to another. And the only reason that SpaceX wants to achieve this type of quick transportation in terms of Earth to Earth, replacing most of the aviation industry, is because SpaceX is ultimately a private company which needs to make profit in order to fund its other projects. So basically, the only way SpaceX could ever build or even put rockets on the path of the moon or even go and build a space colony on Mars, it requires a large amount of funding, and funding that can only be achieved through two ways. One is through continuous investment by proving that their rockets are extremely reliable and are useful in multiple use case scenarios, which is what SpaceX aims to achieve with this Earth-to-Earth system. Also, another way that SpaceX could make profit in order to fund its other projects is by using the profits from this Earth-to-Earth transport system in order to fund its other developments. One of the most interesting things that we need to see is how this rocket system will be used in terms of replacing or an alternative to commercial aviation. But one of the things that a lot of people will be wondering about right now is the cost. So SpaceX speculates the price of a ticket on board the Starship system would be approximately equal to a ticket of a first class ticket, or maybe slightly less than a first class ticket on a normal commercial aircraft. Now again, this does seem expensive, but we shouldn't really think of this type of space travel as a replacement to the commercial aviation industry just yet. It could be an alternative for the higher class members who usually travel by first class as a much more faster alternative at the same price. This would also allow the aviation industry to expand with the growing demands and expand their aircraft to include maybe only economy or business class seats, which again could carry much more people and accommodate the growing population of this world. Now again, coming back to the main point, the aim of SpaceX is not to create an alternative to the aviation industry or even a replacement to the aviation industry. It is to fund its existing developments using the profit that they receive by using the Starship system as an add-on to the aviation industry. Now, after discussing all of this, let us get back to the main purpose of Starship. It is to create a very cost-effective model in order to reach Mars and beyond. So let's just talk about Mars at the moment and how SpaceX aims to use the Starship system to reach the planet Mars. So without going too much in depth, we'll just talk about some of the main problems that SpaceX is going to face while trying to land the Starship on Mars, and just skip ahead all the travel expenses and all the costs, etc. So the thing about Mars is Mars has a very thin atmosphere, and it's very hard to slow down an object entering the atmosphere of Mars. So whenever we're entering the Earth's atmosphere, whether it be a small satellite or it's a large space shuttle, whenever an object is entering the Earth's atmosphere, the air friction slows down the object, effectively making it easier to bring it to a stop or bring it to a controlled landing. Mars is actually very different, and the largest object landed on Mars until now was the Mars Science Laboratory, or the Curiosity Mars rover. So a lot of you might know the Curiosity Mars rover. If you don't know what the Curiosity Mars rover is, it was launched in 2011 by NASA with the goal of trying to find evidence of groundwater and lake stream systems on the planet Mars. It is powered by a type of nuclear energy which we're not going to get into right now, but we'll get into it in a future episode. But basically, the weight of that rover was about 2,000 kilograms, and it was carried in the Mars Science Laboratory capsule, which weighed an effective payload weight of around 4,000 kilograms. So this 4,000 kilogram capsule reached the Mars atmosphere and began to heat up due to the friction caused by, the atmosphere. Once the capsule began to enter the Mars atmosphere, it was traveling through, supersonic speeds. And again, due to the thin atmosphere of Mars, it is not that easy to just deploy a parachute in order to slow the capsule down. There's very thin air, so parachutes also are very ineffective on the Martian surface. Also, the parachutes have to be advanced such that they don't tear up in the supersonic speeds that the parachutes are operating in. So for this, NASA spent years developing supersonic parachutes, which are then used to slowly slow down the capsule. But even that is not enough to slow down the capsule, and it uses a form of retropulsive rocket technology. The rockets are deployed in the opposite direction of the capsule, and which it's used to slow down the capsule even further compared to what the supersonic parachutes were able to slow down the capsule. So once the capsule reaches a close to Martian surface at altitude, it slowly lowers the rover through a set of ropes and carefully puts it on the surface before taking off again and flying and crashing somewhere else. So this is the most advanced type of landing that NASA has ever done, and this was a payload capacity of 4,000 kilograms, which was the rover and the capsule combined. So of course we know that the Starship is going to weigh way more than 4,000 kilograms. It's actually around 1.33 million kilograms. So in order to slow down an object of such weight and such momentum traveling at such speeds, it's going to take a lot of energy. And that's why the SpaceX's Starship uses retropulsive landing techniques, which is similar to ones used on the Earth's surface, except again, we don't know too much about the Martian atmosphere. Though we have collected significant amounts of data, it is still not enough to predict how the Starship will land if it's able to do a controlled landing at all on the Martian surface. So for this, of course, the first few Starships that are sent, maybe the first one or two, will be completely unmanned and not carrying any precious, scientific equipment, because we first have to test out and let the rocket learn how to use its rocket thrusters in order to perform a retropulsive landing on the Martian surface. Now, let's say we land on the Martian surface, all well, all great, we made it, we touched down safely. It raises a bigger issue of how are people gonna get back, if we wanna bring people back at all. So, of course, the goal would be to put people on Mars and have a way to bring people or equipment or, scientific material back to our planet. So, you can kind of expect that, the amount of fuel that the Starship is carrying, along with the amount of people, it's just not enough to take off again, because we use the super heavy booster in order to take off this large amount of payload from the Earth's surface. And again, even that is not enough to allow Starship to travel from Earth's orbit to Mars. It needs to be refueled again when it's in orbit around Earth, so that it has enough fuel in order to perform the retropulsive landing that we see. Also, a lot of you might not know, but it is very difficult to store fuel in space because the radiation from the sun kind of vaporizes a lot of fuel. So SpaceX is also working on a solution in order to find a way to store fuel for a long amount of time in space. So what Starship would do is it would refuel in Earth's orbit. It would reach Mars after a few months, and then it would use the fuel that we refueled when in orbit in order to perform the retropulsive landing, basically landing using the rocket thrusters in the opposite direction in order to land on the surface of Mars. Now, once we land on the surface, we need fuel in order to get back off the surface again. And also, Starship should be powerful enough to take off from the Martian surface without requiring the super heavy booster. And this should be possible due to the slightly lower gravity of Mars and slightly thinner atmosphere of Mars. We should be able to use Starship in order to take off from the Martian surface, but again, this would require an entire filled tank and completely depleting all the fuel that is required. And how will you fill this tank in the first place if you empty the fuel in order to reach the surface of Mars? So this is where one of the greatest innovations was achieved with the Raptor engine. The Raptor engine effectively uses methane instead of the typical liquid hydrogen that you see in rocket engines. So SpaceX plans to generate methane on the surface of Mars, because you can find methane trapped in pockets of ice. You can actually generate methane through ultraviolet radiation with reactions with other molecules and organic material already on the surface. There's a lot of comet dust on Mars as well, which could be broken down into methane. So there are numerous ways which methane could be produced on Mars, and using this methane that is produced along with oxygen that we again produce on the surface of Mars through chemical reactions, we could recreate the rocket fuel that is required and fill up Starship in order to take off from the surface of Mars again. Also, due to the absence of the super heavy booster, the payload of the Starship would again be cut by around half. But at least you have some form of getting off the planet again. And this is one of the greatest achievements, because one of the greatest problems that we have faced until now is wherever we go, we need to carry our return fuel with us. But through this technique of using methane instead of liquid hydrogen in this very advanced rocket engine, we could produce the fuel required on the surface of Mars itself. Again, production of these large amounts of methane would take time, possibly multiple months or even multiple years. And this is absolutely fine, as the launch window, which opens up between Earth and Mars, is only once around 2 to 3 years. So it is fine if we take our time. But one of the most important things to note is when we first send our expedition to start a colony on the surface of Mars, we will require multiple starships which are sent before the humans in order to take raw materials and also numerous amounts of nuclear reactors. So we need large amounts of energy in order to produce the chemical reactions that are required to produce this methane fuel on Mars. So again, nuclear reactors would be carried in large quantities in empty starships and constructed there on the surface to be used to produce the rocket fuel again. Now, there are still numerous problems and numerous factors involved with setting up a colony on Mars. So we don't even have to go that far. Just getting to Mars and coming back is a huge task on its own. And again, there are so many obstacles there which SpaceX has broken through. And it'll take a long time if we want to finish it all in one episode. So this is just a little bit of an introduction, so people really understand the complexity and the difficulties involved in building a type of reusable rocket launch system. It's not easy. It takes a lot of time and it takes a lot of development in rocket science technology. And due to the fact that all of this has happened throughout the few years, mainly most of it due to SpaceX, we are fortunate enough to be able to see a Mars colony within the next 20 to 30 years. Like a fully functioning Mars colony. A lot of you might be also wondering the costs of a Mars colony. So Elon Musk predicts that the cost of setting up a Mars colony would be around 2.1 trillion US dollars. Now, doesn't this sound like a lot? Yes, it does sound like a lot. But then, if you just take into consideration the amount of money that the US government has spent fighting the Iraq War, that's $2.4 trillion. If we focused on space exploration more than fighting with each other, there are so many more possibilities in the realm of space exploration. In the future episodes, we're going to be talking about the exact costs of reaching Mars, how much a ticket to Mars is going to cost, and most importantly, why do we need space exploration? Like, why are we building billions of dollars worth of rockets and why are we sending them out into space? Why do we aim to become a multiplanetary species? So we're going to slowly be going over all of these questions and any other questions that you would like to ask. So do follow us and subscribe to our podcast if you don't already. If you're listening on YouTube, please do subscribe to our YouTube channel. We will also be bringing out a video version of the podcast really soon, where we'll be able to include images and videos of what we're talking about. If you guys have any questions that you'd like us to answer, or if anything you'd like to ask me, which you want me to talk about in the podcast, do follow our page on Instagram. It's at Musk Unloaded. So MUSKUNLOADED, Musk Unloaded. So if you follow our Instagram page, we'll be asking questions regularly and I'll be answering them in future episodes. I really hope that you guys enjoyed the show, and if there's any feedback that you'd like to give me, I'd be very happy to accept the feedback. I'm always looking at ways how I can improve the way I'm telling content to you guys. You can also leave your review if you're listening on Apple Podcasts. Thank you guys for listening. I'll catch you later in future episodes. This is your host Praveen, and you've been listening to Musk Unloaded Space Podcast.